Alright, so I think I'm recording. Let's take a look at our next problem. Boy, you can't see it, but every time I pick up this tablet, I got my wires all tangled up. Alright. Let's take, well, let's find the, there we go. And I think we're ready for problem 3. So 3 has 4 parts to it. Alright, sorry, but I guess I should have done this off camera. Where it was? Did I not get problem 3? Thought I did. There it is. Okay. It's hidden underneath that. I didn't knew I'd gotten it. Alright. The domain of f. The domain is the set of all real numbers, excluding any values that cause division by 0, and also excluding any values that would cause us to take the square root or even root of a negative number. When I look to function f, I do not have any square root, so I don't have to worry about taking the square root of a negative number. I do have a variable in a denominator, so it might be that for some values of x that this would cause division by 0. So we take that denominator, whether it's a simple expression or complicated expression, and we temporarily set it equal to 0 so that we'll know what to avoid. In order to discuss, and if this were a complicated expression, I might have to factor it, I might have to use the quadratic formula. It might be a difficult task to find what values of x cause 0, but for our problems it's definitely doable. Here it's extremely easy that you can see that 3 is going to cause this denominator to be 0. We do not want that to happen. So when we go to describe and write down the domain for D on the set of real numbers on this number line, any number that we plug in is going to be fine except the one that causes division by 0. Well, any value that would there's only one that causes division by 0, and we found it to be 3. We need to avoid that. We want to describe this infinite set. Well, I can't list them all, so they have came up with a way to describe this set called interval notation. And to write this set in interval notation, we look to the arrows to be negative infinity and positive infinity, which are not numbers but an abstract concept. That arrow is going off to the left forever. So as I come in from the left to right, because I write my interval notation, a smaller number, comma, a larger number. Then when you have a break, we want to be in this interval or the next interval, and the idea of a union is how we translate the word or into a mathematical symbol. Or that's how it's more technical than that, but that's the best description for us for now. So if we pick numbers in this interval, or if we pick numbers in this interval, it'll be fine. Any input that we plug into f will have a y value as an output. So that's our answer for problem 3, part A. Alright, so let's take our functions with us to part B. The domain of G. The domain is the set of all real numbers, excluding any values that cause division by 0, and also excluding any values that cause us to take the square root or even root of a negative number. I don't have any square roots, so I don't have to worry about taking the square root of a negative number. I do have a variable in a denominator, so there exists the possibility that for some value of x, that denominator would equal 0. Well, this is an easy equation to solve. If x were allowed to be negative 1, we would have division by 0. If you went and tried to evaluate this function at negative 1, the numerator would be no problem, but in the denominator, you've got negative 3 divided by 0, and that's not going to produce a y value. So when you go to plot points on the graph of g, this x equals negative 1 is not related to any y value. And we need every element in the domain to be related to exactly one y value. That's why we exclude it from the domain. It produces an undefined value, so we say, hey, I don't want that to happen. When we look at a number line, all the other numbers are fine. They won't cause any problems at all. So to describe this infinite set, we use what they call interval notation, and we go from negative infinity to negative 1. We exclude negative 1, and from negative 1 to positive infinity. So there is our answer to problem 3, part B. Part C is the function composition. To find the domain, it's a set of all real numbers, excluding any values that cause division by 0, and excluding any values that cause us to take the square root or even root of a negative number. Two things have to be true if we find that when we're looking for the domain of a function composition. You have to be used to the notation. The first function is actually listed second. It's g. If we have an input for g, in order to have an output, this input x has to be in the domain of g. Otherwise, we will not have a y value, we will not have an output. Now, in a composition, this output becomes an input for the next function. So the same thing is true. The input has to be in the domain of that function in order to produce an output. So this number, the y coordinate that comes from this function g, has to be in the domain of f, or otherwise we won't get a y value coming out of f. Alright, so the domain of g. We looked at it and we already saw that it was all real numbers excluding negative 1. So rather than writing in interval notation, I'm just doing scratch work right now and writing it like this. The domain of f, we saw that it didn't like the number 3. Now, f never sees x. F only sees the output of g. So it's the output of g that I don't want to be equal to 3. See, this input into f cannot equal 3. This time the input is g of x. Well, that's this expression. G of x is equal to, it's equivalent to, x minus 2 over x plus 1. We temporarily set it equal to 3 in order to know what to avoid. This I can write as 3 over 1, and I have this equation that's called a proportion. And this is when you can cross multiply, when you're crossing over an equality. So if I multiply along this diagonal, and then if I multiply along this diagonal, that's one technique to solve this equation. I have x minus 2 is equal to 3 times the quantity x plus 1. Distribute the 3. subtract 3 from each side, subtract an x from each side, and divide by 2. You know, the number of people that accidentally divide by -5 on each side is a little bit more than what teachers would like. So to get the x by itself, the inverse of multiplication is division. So if you divide both sides of the equation by 2, you'll have your answer. Now, so what does that mean? Let's come back up to the function composition. If we took -5/2, which same thing as -2.5, and we plug it into G, the output of G is going to be 3. If you don't believe me, come in here and plug in a -5/2 into G. We've got -5/2 minus 2 over -5/2 plus 1. I claim that this is going to reduce to 3. So if I rewrite the number 2 as 4 over 2, and if I rewrite the number 1 as 2 over 2, in the numerator here I have -9 over 2. In the denominator here I have -3 over 2. And division, that's a complex fraction. Division is the same thing as multiplying by the reciprocal. So this numerator, -9/2, instead of dividing it by -3/2, I multiply it by 2 over -3, or my negative sign got lost there in the so the 2 divided by 2 cancels, and -9 divided by -3 is +3, like we said it would. We knew that when we solved it, that's how we set it up. That's how we picked -5/2, is because it produces this 3 that now causes us problems. Because if we try to evaluate this f now at 3, since 3 is the input into f, that's what this is telling me right here. Well, f always creates a fraction. The input is always the numerator. We're okay so far. And in the denominator, 2 times the input minus 6. And there's the problem, because when we do that arithmetic, we get 0. So, you know, in order for this -5/2 that was the x-coordinate of our function composition, over here is undefined. We do not have a y value that this is related to. So -5/2 can't be in the domain of this composition because it doesn't produce an output. We can't allow -5/2 to be in the domain of the composition. So when we go to write our final answer, the domain of fog, we knew in the beginning that we were going to throw out -1 because it won't pass through G. Now we're going to have to throw out -5/2. -5/2 passes through G fine, but its output doesn't pass through F. So from -infinity all the way to -5/2. Boy, I don't know why that's blinking. I don't know if I'm running out of time or if it's not recording. I hope I don't have to do this again. There's my final answer for C. Now, even though I have a part D to do, I'm going to stop the video. I don't know why that thing started blinking. Maybe it always has and I just didn't notice it. So I'll do 3 part D in another video if I can.